Let me warn you right now, the calculator that we work with in class here does have the LOG button on it. We want to evaluate these things. We want to figure out what these things equal. Just understand the operation, what's happening here with the logarithm. But this LOG, when you type that in the calculator, is not the one we'd want to use for this. All right, and there is a way to type these into the calculator. We'll get to that point at some point. But right now, we're just going to go through and kind of break these things down using kind of some mental math techniques. Like the answer to this is not 60. Do not do that on your calculator. This is not right. Scratch it off. It doesn't work. But we'll use the calculator just to kind of do some, some fraction stuff for us. But we can't type them into the calculator yet. We got to be able to break these things down. In exact form perfectly with just kind of using some mental math techniques. Okay, so here we go. We'll go through these four, and then we'll probably introduce the calculator shortly. But anyway, number one, it says evaluate the logarithmic expression. We want to figure out what this equals. So again, this is no different than seeing something like 3 times 5. You know exactly what you're supposed to do with that, right? 3 times 5 is going to be 15. You're just going to multiply. Okay. At some point, we need your brain to start seeing this as easily and efficiently as you see this. Okay. So what does this mean to do? What does LOG stand for? What does that operation say? Well, this operation says figure out what power we need to raise the number 4 to get 64. Okay, so for a lot of time, for these first couple examples, it's nice to try and write them in the other form, in the exponential form. So 4, the little base 4, to what power, and if we don't know that, this is the answer, we're just going to call it x for now, is equal to 64. Okay, so this is where we spent some time switching these things over. As a logarithm, even my brain doesn't process this as quickly as this, just because we haven't been exposed to these as often as this example. So here we go. Let's see if we can't figure out 4 to what power is 64. We'd want to figure that out. So just kind of guess and check here quickly. If you know your tables, 4 to what power? Let's see, try 4 to the third. Oh, look at that, we got it right away. So 4 to the third power is 64. And that's what this logarithm is asking us to find. 4 to what power equals 64? All right, so 4 to what power equals 64? The answer is 3. Okay, and anytime we're working with exponents, we always got to think about, what about plus or minus? Does 4 to the negative third power give us 64? Does 4 to the negative third? Okay. Well, hopefully you're yelling at me saying, no, don't do it. That ain't going to work, because that's right. Remember, this would be 1 over 4 to the third power. So these answers, being that they're exponents, they're probably just going to be 1. Okay, we're not going to get the plus minus scenario. The base, sometimes when we solve some of those exponential scenarios and mostly the quadratics, we could get the plus minus option. Okay, let's take a look at number 2. So same thing here. 0.125. Some of us probably don't recognize that fraction yet. So if you got your calculator, just make it a fraction. 0.125. If you got to figure these things out by hand, you're going to want to work with the fraction instead of the decimal. So that, that's just 1/8. So I'm just going to rewrite the problem here first. It just says the logarithm of 2 to base 2 of 1/8. And putting it in this form, it makes it a lot easier to try to pick this thing out. But here's what the question's asking us to find. What number do we need to raise 2 to? What power should we put on 2 so that we get 1/8 or 0.0125? 1/8. Okay. And some of us are probably thinking, how do we get the numbers to shrink like that? What exponent's going to make a number get smaller? Okay, and we just saw it on the calculator when we did 4 to the negative third, that number went down significantly to 0.01565, and that's kind of what we're looking for here. We need a negative exponent. All right, so let's try to build this. Let's just try to build this together here. 2 to the negative 1 power. Remember what that does to this thing? 2 to the negative first power just makes it 1 over 2, right? Well, so now we're close. We're at least got the 1 over part, but we need to get it to the 8, right? So 2 to what power then could be 8? So if we take our 1/2 here, and we just raise the bottom number to the third, which hopefully you recognize as being 2 times 2 times 2, which is 1 over 8. So kind of the two manipulations, or the two things we'd want to do to that power, would be to say we want it to be negative. That's going to get to flip over like this. So put a negative power on something, that makes it flip over. And then we want to raise it to the third power to make the 2 into an 8. So if that's the case, this one should tell us that 2 to the negative third power is going to equal 1 over 8. And we can always check these 2 to the negative third. Should give us that 0.125, which we have right there. So we can check these on the calculator real quick too. Okay, so very nice. That's how we get those fractions less than 1, the 1/8 powers to show up, or the 1 over something. You're going to use a negative exponent on that thing. All right, let's try number 3. Log of 1/4. So now the base is a fraction. Again, as long as that's a positive number, it's okay. But the base being a fraction, 1/4 of 256. So what power would we need to raise 1/4 to? So again, the question here is log, base 1/4. It says 1/4. Okay, to what power do we need to raise it up to get 256? Okay. Well, just referring back to the last example, negative power got it to flip over to be, 2 to be 1/2 to some power. How would we get this to flip, you think? Well, hopefully you're saying a negative exponent again. If we just start taking 1/4 and raising it up to powers, if we square it, we get 1 math. Enter, enter, we get 1/16. Because if we square that thing, it's just going to be square the top, square the bottom, we get 1/16. We keep raising that power up to 3, now it's 1/4 cubed. It's just going to keep getting 1 over a bigger and bigger number, which actually makes it smaller and smaller, right? And we want this thing to grow. We want the 1/4 power to actually get bigger in value. We want it to get up to 256. So what we're thinking here is kind of the same step we did on the last one. If we just take 1/4 and we put a negative exponent on it, that's going to make it 4. Okay, 1/4 of the negative first power makes it 4. Okay, well, 4 then to what power is 256? And hopefully we're getting somewhat familiar with these things. And if you're not sure, we can just start checking 4 to the 4th. Right there, 4 to the 4th power is 256. Okay, so combine those two things. We need to use the negative exponent to get this thing to flip over. And then we would also need a power of 4 to turn that 4 into 256. So log of 1/4, base 1/4 of 256 is going to be equal to -4. And there it is. So we get -4 for that one. We had -3. I'm just going to go back and box these for myself for my own reasons there. And we got 1 to go. All right, number 4, log to base 32 of 2. So this time we have a base bigger than 1. 32 is our base. That's a large base value there. And we want to shrink down to 2. Okay. So what did that for us? What kind of power is going to make that just shrink? Okay. So, maybe some people might be thinking negative powers, which, 32 might get us there at some point. But let's just write this out here. It says 32 to what power x is going to be equal to 2. And we want to get that thing to go down. So now, you notice we still want this to be an integer. We want this to be bigger than 1. If we use the negative exponent on this thing, we're gonna get something like a 1/8, a 1/16, 1/32, 1/2. We're gonna get a 1/, kind of scenario. So I don't think this is where the negative exponents play out. Instead, it looks like we want to maybe kind of recall like the root idea. Like, so what's the square root of 9 equals 3, or maybe plus or minus, depending on how you want to look at it. What about and then we had the cubed root. Cubed roots of 8 are going to be equal to 2, right? And we know that each of these had an equivalent power, and that's what we're going to kind of be searching for here. So a fraction power like this, a 1/2 power, 1/3 power, is actually a root, and we can try and figure out, hey, what root should we take of 32 to get 2? So in other words, what root of 32 is 2? And if we think about that, I'm just going to go ahead and start, maybe it's 1/2 power. Is it the square root? No. 32 to is it the cube root? Nope. Is it the 5th root? Yes, there it is. It's actually equal to 2. So, so what power would we have to put on 32 to make it go down smaller but stay bigger than 1, stay an integer in that regards? And that's going to be the scenario where we're going to use those fraction powers, right? Because we can either look at it, the 5th root of 32 does equal 2, or this being just the 1/5 power, and we'll put in the 1/5 power there as our final answer. So kind of the scenarios. This is kind of just a integer base. Okay, bigger than 1, you're going to raise it up to power. It's going to make the number get bigger. Integer base here, bigger than 1. We want the number to shrink down to something under 1, or a fraction, like a 1/8 in this case. We had to use a negative power to do that. This is kind of just the reciprocal of that. We want a 1/4 base, something less than 1, to get bigger. We're also going to need the negative power. And then how about when you have a larger base, a large base here? But we still want something greater than 1. We want to get a value bigger than, we don't want a 1/, that case, and that's where we need a fraction power less than 1 there, a 1/5, a 1/4, a square root. It's some sort of root that you need to take in order to get that thing to shrink down. Thanks for watching.